Let's take a look at this tricky problem in the L'Hopital section. This one starts off with the limit as x approaches infinity of x cubed over 6 times the group 8 over x minus the sine of 8 over x. Okay, so first thing I did was I needed to determine that if L'Hopital's rule applied, or if I could just go ahead and evaluate the limit. And you certainly cannot go ahead and evaluate the limit, but L'Hopital's rule does apply because when you plug in infinity, this first term, of course, infinity cubed over 6 is infinity. But then the second term, 8 divided by infinity, minus the sine of 0, that's 0 minus 0, so we get a 0 for that term. Infinity times 0 is one of our indeterminate forms. So I know that L'Hopital should be able to work with it. Okay, now here's the problem. If you leave it in terms of x, what you would have to do is leave this term in your numerator, and then your denominator would become 6x to the negative 3. The problem with that is it never simplifies with L'Hopital. The denominator just keeps on getting to a lower and lower power, and there's no way to simplify it. So I can say, okay, that's not going to be productive. What is going to be productive, though, is a nice U substitution. Now, we're going to do this all of the time in Calc 2, so it's actually a good opportunity to get used to doing it. What I'm going to do to make this problem easier to work is I'm going to substitute, let's let U equal 1 over x. Okay, now, because I'm substituting U equals 1 over x, that's going to change the limit. If x is going to infinity, then U is going to 1 over infinity. U is going to approach 0. Okay, so then my limit problem, in terms of U, I can say instead of the limit as x approaches infinity, I'll have the limit as U approaches 0. The x cubed in the numerator becomes a U cubed in the denominator. 8 over x becomes 8u, and again, 8 over x becomes 8u. Oh, 8u there. So now, I can say, this looks like it's going to be a lot better to work with. And the fraction is naturally set up too, because I'm going to have, well, this is going to be my numerator, and then I know a 6u cubed is going to go down to the denominator. The reason I knew that that was much better is because anytime you have a polynomial term in your denominator, the maximum number of times you're going to have to use L'Hopital before it's simplified is whatever the power on that is. So I know at the very least, I'm going to have to use L'Hopital's rule 3 times, and then I'll be able to evaluate. And that ends up what we have to do in this problem. So we have the limit as U approaches infinity of 8u minus the sine of 8u over 6u cubed. Okay, so then in that numerator, I take the derivative, and I can say, well, all right, from this step to this step, I'm using L'Hopital. I show that by putting an h over the equal sign. Derivative of 8u is just going to be 8. The derivative of the sine of 8u would be the cosine of 8u times 8. I went ahead and showed that with the parentheses around just to show that the 8 multiplies the entire cosine function. Of course, over the derivative of the denominator, which allows that to become 18 u to the second. Now, at that point in the problem, I would try to evaluate again, but we know that the cosine of 0 is 1, so our numerator is 8 minus 1 times 8, that's a 0. My denominator is going to 0. 0 over 0 is still one of our indeterminate forms, so I use L'Hopital again to simplify out. And again, we still have our limit as U approaches 0. So now I take the derivative of the numerator. The first term just cancels out. Derivative of cosine of 8u is going to be the negative sine of 8u times 8. So since I'm multiplying by yet another 8, I went ahead and just put a 64 out front, and I said I'm going to have a positive 64 8u, or sorry, positive 64 times the sine of 8u. Derivative of the denominator, 36u. Still, though, we're not done because this is still in the format 0 over 0, which L'Hopital can help us simplify that indeterminate format. But if you try to plug in the 0 into your numerator and denominator, you still get that. So you said, still work to be done. I use L'Hopital's rule one last time, and I know that this is the last time because this time my denominator is no longer going to be going to 0. It's just a 36. Derivative of the numerator, derivative of sine of 8u is the cosine of 8u times 8. Multiplying by 8 yet again gives me a 512 coefficient. And now when I evaluate at 0, I know that the cosine of 8 times 0 is just the cosine of 0. Well, the cosine of 0 is 1. Our numerator is 512 times 1, denominator 36. That reduces down to a final answer of 128 over 9. That's a gorgeous problem. But now it would be almost impossible without this key first step. So this substitution in the first step makes this problem so much easier. And again, that's going to be a technique that we're going to need to be using more and more and more so in the next class. We won't see it a lot in this class. This is the first time we have seen it, but it's going to come in handy tons of the time in Calc 2. All right, guys, hopefully that helped with this one.